Hi everyone, welcome to my another lecture on Cauchy's integral theorem. Cauchy's integral theorem. In this lecture, the learner will be able to understand three sums on Cauchy's integral theorem. That is sum number 1, 2 and 3. These three sums I will solve in this lecture. Earlier in lecture 1, I explained very nicely how Cauchy's integral formula proved. I already proved Cauchy's integral formula and a sum I have solved. Okay. So I request to all of you, please see my previous video on complex analysis. Then you will see this lecture. So let's start these three sums. That is sum number this and this. I'm solving first example number 1. Okay. Example number 1 solution. This solution. Evaluate this. Evaluate this. That is, so I'm just deleting this one. Example 2, you see this came AKTU 2010, 2012 and 2016, very important sum. Okay, so sum number 1 I'm doing. Okay, sum number 1, this sum. Okay, so in this sum you will see what is actually the closed curve is this. That means closed curve that is 1 less than mod z and mod z and mod z less than 2. Mod z less than 2. Okay, that means if I draw, this is both are circle, this is both are circle. So this circle is circle of radius 1, this is radius 1 and this circle is radius 2. Okay, so mod z less than 1, that is both the circle, you see mod z 1 less than mod z, that is we can say mod z that is greater than 1. So greater than 1 means shaded region is this, center is 0 0, both the circle having center 0 0. So this is the center. Mod z greater than 1 means shaded region outside, and mod z uh, less than 1, so this means shaded region towards this. So this towards this, so this is the common shaded region. Okay, this is the common shaded region. Now this is the closed curve. Both are closed curve C. Both are closed curve C. So center is 0 0. Center is 0 0. You see this center is 0 0. And this radius is 1 and this radius is 2. Okay, center. Okay, now if we draw a, that is, this is the axis, this is the axis, x axis, that is, this is y axis, or you can say this is real axis, this is imaginary axis. Okay, so imaginary axis and real axis, try to understand. Okay, now to get the singular point, that is fz equal to fz is equal to, what is fz? Fz equal to this whole thing. Okay, this is not a homogeneous function because fz is not defined. Fz is not defined when z square into z square plus 9 is equal to 0. That is z equal to 0 and z equal to plus minus 3i, that is 3i and minus 3i. So these are the singular points. These are called singular point. Why it is singular point? That is, this, in this singular point fz is not defined. What is fz? Fz equal to 1 by z square into z square plus 9. Okay. This is not defined when z equal to 0 or z equal to 3i or z equal to minus 3i. Okay. Minus 3i. Okay. Now, when z equal to 0, z equal to 0, that is that this becomes, that is 0 0, z equal to, that is 3i, that is 0 plus 3i, that is equal to 0 comma 3, 0 comma 3, and z equal to minus 3i, that is equal to 0 plus 0 minus, sorry, 0 minus 3i, that is 0 comma minus 3. Okay, 0 comma minus 3. Okay. So now we have to check after getting the, that is these are singular points. After getting singular point, we have to check whether this lies on shaded region or not. Yes, this is not, that is 0 0. This lies inside the here 0 0. This is 0 comma 3, that is 0 comma 3 means this is 0 comma 3. What do you mean by this 0 comma 3? 0 comma 3 is outside the circle. That is 0 comma 3. You will see this is y-axis, this is y-axis. So this is 0 comma 3 because this point is 0 comma 2, because this is 0 0, this radius is 2, so 0 comma 2, this is 0 comma 1, this is 0 comma 3, and 0 comma minus 3, suppose this is 0 comma minus 3, and 0 0. All the singular points, that is these and these, all are not inside, that is not in shaded region, not in shaded region. These 2 points lies outside the circle, both the circle and this point is, that is at the center, but not inside the shaded region. Okay, not in, lies on the region. Therefore, by Cauchy's integral theorem, that is C, by Cauchy's integral theorem, by Cauchy's integral theorem, so integration C, that is C 1 by z square into z square plus 9 dz, this equal to, directly you have to write 0 directly, because these are not lies in on the shaded region. So this is by Cauchy's integral theorem. This will be that is 0. That means the value of this integration is 0. This is solution 1. This is the solution of example 1. Now I am solving, that is second equation. Very important. I already shown second equation. What is second sum? That is evaluate integration C z square plus 5z plus 6 by z minus 2 dz, or c equal to c mod z is equal to 3 by 2. Mod z equal to 3 by 2. Same thing here. Mod z equal to 3 by 2. Center is 0 0. Center is 0 0. This is the center. Mod z radius is 3 by 2. This is 3 by 2 comma 0. This is 3 by 2 comma 0. So center, this is 0 0. Okay. So center is 0 0. Radius is 3 by 2. So this length is 3 by 2. Okay. Now we have to check fz equal to, what is fz? That is z square plus 5z plus 6 by z minus 2. This is not an analytic function. If suppose only fz equal to z square plus 5z plus 6, then this is an analytic function. When fz is an analytic function, then integral fz dz is equal to 0. Directly you will write 0 without seeing any closed curve, or any closed curve. This will be 0 when fz is an analytic function. But here fz is not an analytic function, because fz is not defined. Fz is not defined when z equal to 2, that is z minus 2 equal to 0. So this is the singular point, that is z equal to 2 can be written as 2 plus 0 into I, that is 2 comma 0. So this is 1 by 1.5 comma 0. So 2 comma 0 will be here. Whether after getting the singular point, this is the singular point. Okay, this singular point not lies inside the circle, this is outside the circle. So if it is outside the circle, that means Cauchy's integral theorem says that when a function fz is analytic function on any closed curve, that means we can say integration any on closed curve fz dz is equal to 0. But here fz is not analytic function, so directly we can't say this integration of this value along a closed curve is equal to 0. But we have to, in that case, we have to see whether fz is not defined at for what values of z. This is at 2 0 when z equal to 2. This is not defined. So now we have to check whether 2 0 lies inside the circle or outside the circle. If it is inside the circle, then we can't say this value is equal to 0. If it is outside the circle, that is this outside the closed curve, this is the closed curve C. Outside the closed curve, that is 2 comma 0. So we can write by Cauchy's integral theorem, Cauchy's integral theorem, integration C z square plus 5z plus 6 by z minus 2 dz is equal to 0. Directly we can write 0. Okay, because the singular point I am getting here, that is z equal to 2. Z equal to 2 is a singular point. This is not lies. This inside the circle. This is outside the circle. So by Cauchy's integral theorem, this value equal to 0. Okay. Now this is example 2. Now I am solving example 3. How to solve example 3? Just follow me. I am solving example 3. Okay. Okay. Solving example 3. Solving example 3. Okay. Example number 3. Example 3. Evaluate. That is very, very important. Evaluate z minus z plus 3 by z square minus 2z minus 2z plus 5 dz. C is a circle, that is z minus 1 is equal to 1. Z minus 1 is equal to 1. Okay, z minus 1 equal to 1. Now you see, what is fz here? Z plus 3 by this. This is not a homogeneous function. Sorry, this is not a analytic function. If it is an analytic function, then directly we can say under the closed curve. Directly we can say this value, integration of this value is equal to 0. That is, if fz is an this is fz actually. What is fz? This is fz. And what is the closed curve? Closed curve is this. Okay. So fz is not an analytic function. So we can't say integration of this along any closed curve is equal to 0. We can't say, because fz is not an analytic function. If fz is a that is analytic function, then we can say directly integration along closed curve fz dz is equal to 0 by Cauchy's integral theorem. Okay. So when fz is not analytic, then what will you do? We have to see fz equal to this, that is fz here, solution, fz is equal to z plus 3 by z square minus 2z plus 5 is not defined when, that is z square minus 2z, z square minus 2z plus 5 is equal to 0. This implies z value you will get minus b, z equal to minus b plus minus root over b square minus 4ac by twice a, that is 2 plus minus root over minus 16 by 2 minus, that is 1 plus minus 2i. This again can be written as 1 comma 2 and 1 comma minus 2. So these 2 points, that is these 2 points are known as singular point. Okay, the singular point, that is for z equal to this value, that is this fz is not defined. So this is the singular point. Now we have to check whether these two singular points, that is 1 comma 2 and 1 minus 2, so lies inside the closed curve. If it is not inside the closed curve, if it is outside the closed curve, then directly we can say this integral will be 0 according to Cauchy's integral theorem. Okay. So we have to see what is the closed curve here. Closed curve, this is the closed curve. You see, this is the closed curve. Okay. And this is the closed curve having center is 1 comma 0 center, radius is equal to 1. This is the center. Center is 1 comma 0. So center is 1 comma 0. This is the center. 1, comma 0 is the center. This is 1, comma 0. So radius is also 1. That is from this to this 1 and this to this is 1. So this is your x real axis, that is x. This is conjugate axis. This is conjugate axis. Okay. So you see, so that means from this to this is also, this is 1, comma 0 because radius is 1. Radius is 1, so it is 1, comma 0. And here from this to this is 1 because radius, and here it is 1, comma 2. So here is 1 and this is 1, comma 2 will be outside that circle. This is 1, comma 2. Again 1, comma this is 1, this is 1, comma minus 2. 1, comma minus 2. Both the that is what we have seen. That is both the singular point, that is 1, 2 and 1, comma minus 2. These 2 points lies outside the circle. This is the closed curve. This is the closed curve. That is both the singular points outside the circle, lies outside the circle. So we can't say, this is y axis, imaginary axis. So we can say by Cauchy's integral theorem, integration c z plus 3 by z square minus 2z plus 5 dz is equal to 0. Directly you can write this value equal to 0. Why this is 0? Because these 2 points, that is singular point, if z is not defined at these 2 points, then we can say by Cauchy's integral theorem, this integration will be 0. Okay. Or another way you can say, suppose fz equal to, suppose what I am saying, suppose fz equal to z plus 3. Suppose integration this z plus 3 dz. So z plus 3 is a polynomial function. Then every polynomial function is analytic function. So if fz is analytic function, then no need to see that is whether the closed curve is a circle, is a square, is a rectangle. We won't see. When fz is a that is the analytic function, directly according to Cauchy's integral theorem, directly integration fz dz equal to 0 if fz is an analytic function. Okay. I think everybody understood very nicely, very clearly. Do you like this video? If your answer is yes, then don't forget to hit the subscribe button and notification bell. Okay. So keep watching, keep sharing, keep commenting this video with your friends. Don't forget to hit the subscribe button and notification bell. I'll come with my next video, interesting video. Till then, bye bye. Thank you very much. Thank you.